I'm glad to be here today, and I hope you will enjoy this session. Um, this is a story that started about 2 years ago. I'm going to tell it in a minute about. Actually, the quality dashboard is quite a bit of a cheat in the name because we didn't arrive at the dashboard. I'll go into details in a minute, but it's a story about how we put on a lot of effort and infrastructures and reports in order to improve the quality in a development team, and what the thinkings about it, how we managed to do it, and I'll show you examples of the reports that we put out and how we did it. And the main point I want you to take from this is that yes, it took time and money, but with a bit of thinking, I bet you can do something like that in your organization. And it proved quite fruitful for the team I was working with. Now, it is a bit of a long story, so get some coffee first. I hope you already did. If not, run and get some, because in the meantime, I'm going to talk about myself. So my name is Gil. I'm from Israel. Ahead of you on the clock. I'm a consultant, and I work with developers and testers and agile teams and whatever goes around software development. And you can go to my site, testingguild.com. I'm also the author of 2 books, Everyday Unit Testing and Everyday Spring Testing. And my story begins with my experience, which is test automation. So you can always catch me on email and uh, Twitter as well. And that's about me. I hope you got the coffee. So my story begins something like almost 2 years ago, a year and a half ago, almost 2 years ago, and I started working in a bank. And the team that hired me there um, was called the REST team. You can probably guess what they did. And I was brought on to do some test automation and teach the people how to do it and so forth. Well, that was what it said on the email. I had to do some digging to see what's going on there. And there was basically a situation there. So the REST team obviously created REST APIs. They were creating their own REST APIs and logic for calling the mainframe. This is a bank, they got a mainframe. So part of it was just getting data in and out, but also some kind of logic, and they developed lots of APIs, hundreds of APIs, and they wanted to test them. At that point, when I joined between a year and a half and 2 years ago, the situation is that there weren't any unit test ones completely. Those that were written like 2 or 3 years ago, they were out of date. Most of them were ignored. API tests were beginning to be written, but there were no reports. So if people wanted to know how much of the code or the APIs, how much of the APIs was covered, they filled in some manual reports. So and basically the report would say an API is covered if it got one test. And there was no, you can probably imagine what an automated test, a single automated test check on an API, not much. There was no indication whether this test was good, if it covered the happy path or not happy, the not happy path, what it checked. And you can probably see that at this point, there was no visibility into what is the quality level of what they were developing. In addition, when I joined, they started looking at SonarQube. So installed people who worked with SonarQube. This is like a code analysis plus stuff tool that you can install. They were installing it at the time. Not much use for it. There were no tests. They were beginning to put it, connecting it into the infrastructures. There was a CI system using Jenkins. So they were starting to tie things together. But again, it was just the beginning. People were not really going into SonarQube to see what quality metrics that SonarQube collected were actually there. The culture, which is also important to my story here, is they were calling themselves agile. They're not really agile even today. One of the main things that of the decisions that they did before I joined was to toss out the testers. So the REST API team and other development teams as well in the organization did not include testers. There were testers, we call it the manual testers today, that were receiving the code APIs later, but there was no automation involved. There was one guy who was writing system tests like Selenium on the web, but he was told what to write, so he isn't really a test. He was the more automation engineer. But most of the quality management was depending on the developers themselves. And that was a problem because nobody taught the developers how to test. Yes, they had tools. Some of them worked with JUnit before. Like I said, there were like three-year-old tests that looked okay sometimes. But basically, the thinking is testing is something that we need to learn, and this is where I come in. One more thing that was important to our story, that there was a very good leadership in terms of DevOps and automation. And that means that we got answers, we got support as the story evolves in a few minutes that helped us. And there was a want and a need to automate stuff in order to connect stuff together and to help bring on some metrics as well. Some of the testing methodology came from this group, the DevOps, but they were not testers. They were not. They didn't have an experience in testing. So what happened is that they directed the developers to which tools to use and how tests should look like, but not more than that. Management was kind of an old school. This is a bank after all. And very organized, very structured. Like I said, agile was sort of a fad to them, and they were not thinking about this, but they were listening. And this was good because it helped roll out what I'm going to tell you. And this is one of the key things that helped this thing succeed. So they were listening, tried not to control too much. And this is where I came in. So a few months after I joined in and started teaching the developers how to write tests correctly, I was asked to write an automation testing methodology document. I didn't invent too much, like the pyramid and stuff like that, and what to check and coverage. And there was a lot of things that I'm going to cover in this session that were important to me, but managers looked at what can we check? Coverage numbers, of course, we want those, and obviously in this team and other teams, all they had until now were manual reports. So they wanted to use the automation to report something that they could use in order to improve. And so we're talking about 6 months after I started working with the REST team. The management, after having the methodology and thinking about it, decided that the teams themselves could not concentrate and collaborate on creating this kind of effort in reporting, at least what we wanted. Yes, coverage could be like extracted from Jenkins, but they wanted a bit more. So they decided to dedicate a group, call them the management squad, the measurement squad. Sorry, squad was very. If you know it from Spotify, the Spotify model, the name squad really resonated with everyone. So the measurement squad was founded. On the squad, basically there were three. There was the team lead. The team lead came from machine learning, data sciences. What we did was not machine learning or data science related, but he wanted to get a foothold and try to use this group to get a foundation so other projects will come to it. And he was quite successful in that because he was also a good politician. And we needed that. Apart from that, we had a programmer. The programmer was a Python programmer. And he would do all the scripting needed to collect data and stuff. And that was me. And at the beginning, all I did was basically the methodologist. I would tell them, yeah, we need to concentrate on measuring this and that. But later on, I got to play another part. With time, as this group succeeded in supporting more and more projects, we got a bit bigger, we got a project manager, not a developer. And this is where we stand right now. And you probably want to know what we did, because otherwise this session would be a bit boring. So the first thing we did, though, is, yes, we got a mandate to report measurements, but other than that, we didn't do anything. So we had to create our own goals. And this is important because without goals, yeah, we just wander around and basically, without those, you'd probably start going to the internet and checking what is everybody else measuring, probably going to come to code coverage, do that. And as you will see, you can be a lot more helpful than that. So we had two goals. The first one is to bring management useful report. Management put us in there and they want to see the big picture. Remember, they didn't have any visibility on what the developers were doing. They didn't have any visibility of the quality. If you think about it, if you have like hundreds of APIs, what does one API equal to another? They didn't know. And obviously, with the talks that I had with management and Tillman, then they understood that the report that they do have is not enough. One goal was to satisfy management. They put in the money, they put in the budget, they put in the time. We want to help them see what's going on. The second one was more important so that we can do something, because most of reports just bring numbers to the managers and they bring it to the developers and they say, fix it. But the developers don't know where to start. So the developers needed useful information to show them, you need to fix this, to understand why they need to fix this so they don't repeat that. But we needed to bring the information to them. And the main thing is to focus on things that matter. Meaning, if I brought something to the developer that may be important to me, but not to him, he'll see that as additional work. And either will do it or not, depending on how they perceive it, the team leaders perceive it, and so on. But we decided on focus on things that will matter for the developers and basically respect their time. So it will not be just additional work for them, but it will be work that they will see what the value is, and they will either want to do more of this to get more value, or less of it to get less work from our reports. And we decided on two things. The first one was clean code. The second was effective tests. Both of them cut to the heart of the developers' work, because if you don't do these things, um, two things happen. First, you waste a lot of time on debugging, and when you enter new functionality, you break stuff. You know it is. But so we said we're going to focus on these things, and we're going to report this. As you will see in a few minutes, we got a lot more than that, but that was the beginning. I think it was like a month after we started, we already shown results on a real project that was working. It was the beginning, but just working alone and doing like, is that a good report without tying it into a real project? Didn't make sense to us, didn't make sense to anybody. Yeah, we actually wanted to see how these things work for a real project, not just for us looking at the reports, but can the reports be useful to the project themselves? So we got ourselves a guinea pig. So our guinea pig project was basically a small project, a single developer project, meaning we had he had a project manager, he was also a product manager at that point, and we had the developer. And this developer was good for us because he was willing to look at what we produced him. There was no automation by then. We just created the scripts, first of all by hand, then by scripting. It was not tied to continuous integration, stuff like that. But once a week, we brought him something to look at, and he was willing to look at it. He was willing to fix what we reported as bad, and we got good feedback about these things. Do they matter? How do they matter? And so on. So it was really like a real project, a software project with a real client. And the more we got this, we got more projects, basically expanding our kingdom. So let's talk about what we were measuring. So I mentioned SonarQube at the beginning, and this was something like 8 months after I started working there, so something like 8 or 9 months after SonarQube was implemented. So basically, SonarQube was tied into the continuous integration. So if you wanted to see what was wrong with the code, and there was a lot of things wrong with the code, you could just go there and look, but nobody did. And that was one of the things that we identified as a problem, or basically as the solution. We needed to bring things to the developers. They will not do this on their own. Like I said, everything in the mentality that was thought of as additional work, they will not do unless it's easy to do. Before that, remember, we wanted to not waste their times, and that's where I went into SonarQube and went over the rules for all the quality rules about code analysis that it has, to make sure that what we tell developers, hey, this was flagged, and fix that, doesn't waste their time, so that it creates some kind of value. I think this was the first time I did that in a while, and I was surprised that what is now, at least for Java and in the default gate for SonarQube today, is not bad. The list of rules there, of exception of what it flags, is not that bad. We filtered a few, and we got to at least a few hundreds that it would first flag if something was not out of line. But like I said, having that in SonarQube is not enough. You need to extract data and bring them to the developers so they can fix it. Otherwise, it wouldn't work. So we used SonarQube's API to pull this data. And what you'll see in the report next are a couple of things that are high level in SonarQube. You get the reliability and tech debt and maintenance, things that don't help developers, but might help managers. But I was really against putting tech debt in because SonarQube calculates tech debt as in time, which is completely wrong, and they don't understand what tech debt is. But like I said, this was a teamwork, and some of the fights I wouldn't get everything I wanted, so this stayed in, and this was an easy win. Getting the data out of the SonarQube, according to the API, put it in a report, helped us put a report both for managers and developers very quickly. It looked like this. So you have like the number of issues, and you'll have the tech debt, and for each project, you'll see the size of the project. You'll see the trend, which was not good at the beginning, as you can see. Technical debt was high, nothing was getting better, but it did get better a while. And there was color coding that we put in, and basically you can see it's very visual. You can see at a glance what's wrong or how things are looking, and this is very manager view thing. It's very important to explain what you're seeing. You see that this is the legend that comes with every report. We don't rely on people understanding what green is and what red is also, although the idea green good, red bad is there, but you'll see that there's an explanation for everything and what it means. We couldn't rely on people seeing it for the first time and then remembering it. We couldn't rely it being the same people looking at it all the time. So the explanation always comes in the report. But that was like easy, right? We didn't do anything. We just brought something from the outside. That's cool, but they've got SonarQube, right? That's not like something that we could provide. Let's talk about these things. But these things was like the kind of innovation we were looking for. And I'm going to talk about documentation. I'm not going to talk about documentation like Word documents, but Swagger documentation, API documentation. So I started working with the REST team, but there were a lot of teams doing API work. And many of them created APIs for internal usage by the bank, other teams, but also external APIs used by other collaborators with the bank. So documentation or Swagger documentation or API documentation is very important. And the way they did that is that you can create Swagger documentation in two ways. One is create it and then generate the code from that, or start with the code and generate the Swagger from that. And the bank was working in the second way. They created the Swagger APIs from the code itself. So we thought, we asked the question, is the documentation, is the Swagger docs that are created good enough? We didn't know what good enough is yet, but we started looking at things and we found out very interesting stuff. So what we did was we took the API tests that people were writing. Remember, this is like 6 months, 9 months after I started working with them. So we started compiling more and more tests and a lot of API tests. And we asked the question, these tests operate APIs. Do they match the Swagger documentation as it is? And we were surprised to find out, no, not always. So you can see here a table from the report that we have. So what you can see here, if you look at, I don't know, update client consents, which is an API, you can see that the Swagger documentation said it might return a 204 status, but we didn't have a test that operated the API and proved that it can do that. So we have an untested response. On the other hand, look at the create consent one. You'll see here that tests were operating the API and the tests were returning 207, 203, but in the Swagger documentation, it was not there. So this kind of the changes, the differences that we found kind of mattered to the project managers who were actually exposing these to external customers, external collaborators. So we found out there was a discrepancy. This discrepancy mattered to our customers. Our customers were the people who were reading the reports, and they fixed that. And this is where the people just got these guys, the measurement teams, are doing something interesting, something valuable. How did we do it? Basically, like I said, we already had the infrastructures in terms of CI and CD, so tests were running already. And we had to add a bit of logging to them. And we collected these logs. Specifically, these were Spring APIs, so a lot of the logs of what was occurring in terms of the API calls already was logged, but some of them were not. We needed to match those to the tests. So there was a lot of, a few, not a lot, some logging that were added in order for us to consume them and parse them. We then matched to what happens in the Swagger API, the Swagger server for these APIs, kind of collect the data from here for here, match them, and compared. So like I said, this was very interesting to some of the people. But then we said, okay, that's cool and it helps the product manager who operate that, but we want to remember, we wanted to say about quality something. How good are your APIs? And this is my experience coming in more because I come from more of a unit testing and testing experience. And we wanted to give a measurement of how well people tested their code or tested their APIs. So what we did is said, let's look at the API itself. And remember, I told you at the beginning that something was covered if it had one test, when we obviously don't know that it's not. So we said, let's look at the minimal number of tests that we might want. What would that be? Well, obviously, look at the parameters of this API. And depending, there's a correlation between the number of parameters to the ones in the how many tests I need. We don't know the context. We don't know how about what this API actually does. But we know that if there are a big number of parameters, they probably need more tests. So what we said was like this. We're going to look at the API Swagger documentation. All the APIs are there. We're going to count the parameters. And we said that for every parameter, we want at least 2 cases tested. One would be a valid one would be an invalid one. What is valid and what is invalid? You decide. We don't care. We don't know what that valid and invalid is, but we want to at least ask, are you testing this well enough? And the answer is, if you have 0 tests, probably not. If you have 1, also probably not. So you kind of give the minimum of what you probably expect to have in terms of tests and compare it to the signature. So for example, if you have this API get address by ID and you get an ID, single parameter, you probably need 2 options. Which options? I don't care. I can check that. But I know that I would test for a negative number as well. Why? I'm coming from a testing mentality. Um, if I have something like that, the string can contain many things. But I'm saying I don't care. If you just check two names, you decide if it's an empty or null or whatever, and you give two cases, that's enough for me to say, well, at least the bare minimum is done there. So 2 parameters, we get to 4. And this is how we got to this kind of report. So you see that for each API, there are 3 bars. The blue is the number of tests that we calculated as required. The orange is how many were there. The green one is more about the undocumented that I showed you earlier. So you can see that for the update agreement one, there are 4 tests that we counted that there should be at least. There are 4 tests actual. We don't know how good they are, but we know that probably this is a better situation. All the APIs where there are just blue bars and no orange bars at all. So this gave a visual to a project with many APIs saying, well, how good are these tests doing? And this is where project managers were actually saying, we're releasing something that was not tested. Let's write tests. This is very important for us, especially for putting these APIs out. We also started, again, from the management point of view, adding a couple of measurements or metrics or new metrics that were kind of giving a higher level view of what's the situation there overall. And this is one of them, the Swagger documentation integrity. How good is this thing in terms of documented? We kind of took the numbers of the required things that were documented and count them as a percentage of how many documented plus undocumented we found. Again, something that made sense once you understood how it is. High number, good, we kind of documented. Yes, we want to fill in the blanks. And some of them wanted to be 100%, but some of them were kind of low and they said, we need to pick it up and fix this. The other thing we wanted to fix, or I wanted to fix, was the quality of the tests. So again, the beginning point was there were tests, but nobody looked at them. And when I started looking at the tests that were written, a lot of them were like copy and pasted, obviously. But there were patterns repeated that we wanted to get rid of those that didn't make any sense or were not helpful. And also move people in the terms of the methodology that we're talking about in the document. So we focused on a couple of things. First of all, we ignored tests. Like I said, there were more than a few tests that the teams have collected over the 3 to 5 years. A lot of them were in comments, a lot of them were ignored. And we wanted to get rid of them, clean up the code base. So we wanted to flag those. The second thing was, and this was continuing because when I started working with the teams, I started pushing them towards writing unit tests or isolated tests. And this didn't catch up too much. So the methodology document was talking about the automation test pyramid, a lot of unit tests, less though of API tests. Most of the team had it backwards. So they had a lot of API tests or accumulated more and more API tests and not enough unit tests. And I wanted to show that. this comparison to push people to say, we are not working, at least according to the methodology. Let's explore this thing called unit tests more, but I needed to show that. And the final thing was the quality of the test. What are we checking there? And this is the asserts. Now, how do we do that? Now, that was a problem. You can't get this information because nobody collects it. It's not in SonarQube. It's not in a JUnit report. So we wrote our own tool, and this was basically a code parser for the tests. We called it the test analyzer or test analyzer tool. Last I heard, there was some kind of talking about outsourcing, not outsourcing, making the source available, but I wouldn't hold my breath. This is a bureaucratic organization. It will be a while until we do that. But I wrote most of it, all of it almost. And basically, it was for the Java tests. And it looked at the code and basically did what I gave you. First of all, it flagged out the ignore tests. Second, I tried to identify what is a unit test and API test, and mostly it was right. By the way, written with TDD. I was very proud of that. So it was completely covered. And the final part was looking at the asserts. So, like I said, at the beginning, it was manual. If it had a test, the API was considered covered. Look at the test, you might find there are no asserts there. Or a lot of the API tests were checking just for status. Or they were checking that the body was not null. The body, or the JSON body that was returned from the response, which is nice. But if you start thinking about them, a lot of these tests didn't go to the mainframe. It was a mocked response. So checking that something is not null is nice, but it was never null. So these kind of asserts would probably never fail these tests. Same with the status, like they check that the status came as okay or 200, but yeah, why wouldn't it? It's a recording. So we wanted and started ranking tests by a very simple ranking system. None is bad. Assert not null, which was used very extensively, checking that the body was not null. We said it could be better because it can be replaced with something better, like either checking a specific field in the JSON that was returned, or anything. But assert not null, probably if you have another assert and you check on the body that it's not the body contains a field, if it's null, it will fail. So assert not null can be replaced with something better. And we said that for unit tests, we're checking for at least one assert. For an API test, we expected two, and one should include a status check. That's basically the bare minimum of what we expect of an API test. And you can see a report that has this information. They would, the team still calls API tests component tests. Not sure where this came from. This is how they talk. So what you see in component tests and unit tests are ranking of, first of all, how many tests there are, and you see the quality. So what is a quality? So everything that failed our ranking we called them inadequate. We had like a half an hour discussing how we're going to report that. And we finally settled on inadequate, because these are not bad tests, but they can be improved. So we call them inadequate. What you see in green are tests that are meeting our ranking. You can see that at the bottom, again, the agenda is there. For API tests, you get adequate, which is green, only status, only not null, and no asserts at all, which you can always improve from the list, these three. Unities are basically the same, only they don't have any status checks. So we're not counting them. And the developer get these tests names and saying these are inadequate. In this test, there are missing, there are no asserts. Again, what are we looking for? To get the developers to write tests that help them. So if they wrote tests that are ineffective, let's fix that. And switching back to the manager's view, we wanted, again, to look at it from the manager's point of view and answer, well, how confident are you in the quality of what you're releasing? So we created the confidence interval, which basically takes into consideration the test scores that we've collected, the line coverage that we got from Jacoco, the code coverage tool that we're using in the tests, and the number of APIs. So basically the confidence it rises when you have big test scores because the tests are good, big line coverage because the coverage is good, but it spreads out the more APIs, kind of lowers it. So you get a number saying, well, how good is your product? Again, very helpful for managers. And like I said, this kind of thing at the beginning was a few projects when we added stuff like I showed you, but then there was kind of a period where we settled in because we needed to support more projects. And at this point, just having our own, let's call them servers, which was one computer running it, we required more infrastructure because we wanted to support more and more projects across the bank. So first of all, we needed to document and say how this is how you connect to our system, if at all, but more of it was changing the infrastructure from our own file system that we've collected to an ELK-based system for logging. So a lot of the logging went to that system. We kind of consumed the logs from there. The results that we produced were produced there, so reports can be created on other tools. So a lot of the work was done in order to create better integration with the software infrastructure that was already in the bank, but was even getting better. And a lot of the work in the following months was more about better integration, so we could support multiple and a bigger number of projects. Today we're kind of not yet of a crossroads, but let's call it the third wave, the beginning of the third wave of what we're doing. And I want to share with you things that we're considering. And we're considering things that are basically according to the same goals that we had at the beginning. So both helping the managers see what's happening and the developers helping themselves to fix the things that matter for them. Basically, we're looking at two things. First of all, the code itself, and then the tests. So this slide's about the code. In the teams that I've worked with, but I saw other code as well from other teams, code could be very complex. And I'm not talking about the mainframe code, because this thing we don't touch, like nobody touches that. But new code meaning from the last 5 to 7 years written in the bank, it could get very complex in terms of logic. Some of them are multiple API calls, getting information, processing, and so on. And we know that code complexity hampers development. It slows things down, especially specifically if you want to add stuff. So we want to get the same thing that we did from the beginning of SonarQube, get information there, bring it to the developers in terms of this is too complex, this logic is too fragile, these long methods and files specifically. I saw um, based on the architecture that the people were writing in, so they had like vertical layers, which you can probably imagine if you develop something like that. But the copy pasting stuff created very long non-modular code. And we want to break that in. If you can break that, you can also write unit tests, which is another goal. So first of all, flagging these things that are hampering. Second, magic numbers and strings, flag those in the code. In order to do that, we need to parse the code. We haven't done it yet. We've done it for the tests, but not the code itself. Magic numbers, if you see something in the code, if ID is bigger than 17,388, you're probably wondering why did I pick this number? What is the meaning of this number? Usually there is an explanation which you can do something with it, but change the code, refactor, even write a comment might be better than just picking this number and keeping it there. So we want to flag that as well. But the thing that we're looking at currently is the API coverage and risk. So think about code coverage. Code coverage now, code coverage tools basically look either at the whole project or modules or functions. And SonarQube can give you these numbers. But if I ask you how covered is your API, you don't have an answer for that. Somebody have to go into the code coverage report and stitch the functions together to come up with a number. So you can see this API is pretty well covered. This API is not so much covered. And again, the product here are APIs. So we want to do that. We want to look at how well API coverage is, how coverage by tests exists, how much isn't, and how much of a factor of risk is it if you take into consideration the documentation stuff that we did before. So this will probably be the next few months we'll be working on that. On the tests part, we want to check a few things. We want to check test redundancy. If you have a multiple API test, that I'll give you an example in terms of unit test. You have a calculator, of course, and you want to check add, and you give it two numbers, 2 and 4, it comes out 6, and you give another test, gives it 3 and 5, and it comes out 8. Great. But there's a redundancy here. Both tests will fail if add doesn't work, right? So it does give you more information. But redundancy doesn't have to be a bad thing, because if you're covering the same thing with a unit and an API test, for example, and the unit test passes and the API fails, you know that something is wrong outside the code. So giving a level of ranking for the redundancy is something that's very important to give you more information where the problem is. So that's one thing. Other things, slow tests. If you look at the test report, you'll see how long any test ran, but we want to encourage people to write unit and isolated tests separately from API tests, because this way the unit test will not run slowly with the other API tests. So we want to report this in terms of organizing the tests. Complex tests that should be split, it's an idea. There's a lot of workflows that are tested by API tests. but they can be split into isolated API tests. So we're thinking about those. And finally, we're looking like to expand this, because up until now, we were looking at Java only, and more than that, JUnit and Java and Spring. That's basically was our whole world. We know that there are teams aching to join this from C# and JavaScript and Python. So expanding that would be like a major thing. Finally, we want to get another an actual dashboard, because up until now, we kind of reported things at the project level, which was nice, but we're hearing more and more things around the department level. We want to see how teams are doing rather than separate projects. So when we get there, there'll be an actual dashboard that collects all this information in and shows it somehow. So we're coming to the end almost. I hope you got all your coffee injected. I want to get back though to the things that make this successful. And this has nothing to do with the actual coding. It has some, but... So the key ingredients for making this thing work, and it obviously works because I'm still working with this team. And the team exists, and we're developing more and more stuff. So first of all, it's the backing of the management. They wanted more, they created the budget for that, they were listening to suggestions, they were providing feedback, they were part of the program, always. It's not like they initiated and then moved out. So management, and that means department leaders, team leaders as well, but mostly the department leaders gave us the engine to move forward. Second was focusing on things the developer knew what to do. So we gave the developers like a worksheet. This is your task list in order to fix. This is why. Don't do that again, because you might need to do that to fix that again. So the focus on the developer effectiveness, or respecting the developer's time, was very important. Show results early. Like I said, I think after a month we started thinking about ideas, we already showed result on a real project. And this comes back to the next point, which is transparency and exposure. A lot of what we did and directed us to other projects as well was the publicity, that we showed people the results, other teams from the guinea pigs that we started with, and they wanted that, and they wanted more, because we explained what's the benefit. But more than that, the transparency was there from step one. We always told everyone what we're going to do, involve them in what we're doing, and show them the results and got feedback, and they were already working with us rather than just waiting for our product. The final part is something that, depending on your organization and your inclination, you might be depending on, but you have to be part of the system. That means we got budget, we got people to work on stuff, we needed to provide stuff. We couldn't fight. Remember the metrics that I wanted, but I said we put them in because management want them. You have to play within the system, because you can't fight or tell everyone, I'm going to teach you what's right. It won't work. Collaboration is very important. And I think these things are the things that made things work. The cool thing is that Yes, it required budget, and yes, it required effort. But even if you don't have those, you can take a lot of what I thought, what I told you today, and say, well, these things are important to us because we can make better improvement in that. And my point is, you probably can do that in some way. It's not like you need a big wig consultant coming in and show you how to do this with super tools. The tools are there. Mostly SonarQube is ubiquitous. Jenkins is ubiquitous. You can do that. Yeah, the test analyzer is not, but you can replace that with code reviews as well. You can focus on what you want to fix and create those things. And with that, I will finish. Hey everyone, if you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.